heat. Okay. So see here, heat is a form of heat is a form of energy. Heat is a form of energy which can be transferred which can be transferred from one object to another object to another object. Okay. Now see, suppose this box, suppose A is a box. Okay. This box is made from copper. Okay. Now another box, same identical another box. Okay. Identical in size, shape. Okay. And made from it also copper. Okay. Now see here, if we increase the temperature of box A, then this heat can be transferred to box B. Okay, that means heat can be transferred from one object to another object, one object to another object. Okay, so heat can be transferred by three ways. Heat can be transferred by three ways. Okay. First one, conduction. Second one, convection. Second one is convection. And third one is radiation. These are three ways to transfer heat from one object to another object. Okay. Now see here, suppose this one is the atom A and this one is the atom B. If we increase the temperature of A, okay, when heat is transferred, when these two objects are connected to each other, when these two ways require material medium. Material medium. These two ways require material. Now radiation. So the radiation is the way of transfer of heat. This radiation does not require any material medium. That means this does not require material medium. Okay. Now this does not require material medium. So how the radiation can be transferred? This radiation can be traveled through radiation. It can be traveled. It can be traveled through electromagnetic wave. Okay, so radiation can be transferred with the electromagnetic wave. Okay, so this radiation can be traveled through material and vacuum also. Vacuum means no any medium, so it can be traveled in material and vacuum also. Vacuum means there is no any medium. Okay, so radiation can be traveled through material or vacuum medium. Okay, so it can be mostly traveled through vacuum. Okay, and this radiation is the fastest way to transfer of heat as compared to conduction and convection. Okay, so see here, radiation is the fastest way to transfer heat from one object to another object okay, as compared to conduction and convection. Okay, so see here, these are the basic concepts. Okay, and most important. Now what is meant by heat? Heat is the form of energy. Heat is the form of energy which can be traveled from one object to another object. It can be traveled from one object to another object. This heat can be transferred by three ways. First one, conduction, convection and radiation. Okay, now the conduction and convection, these two ways are required material medium. These two ways require material medium to transfer of heat. Okay, and the next one, which is most important, radiation. Radiation is the way of transfer of heat, but this way does not require any material medium. Radiation does not require next one, radiation is the fastest way. Radiation is the fastest way to transfer heat. Radiation is the fastest way to transfer heat from one object to another object as compared to conduction and convection. As compared to conduction and convection. Okay, that means radiation is fastest. Okay. Now next point, interaction of thermal radiation. Interaction of thermal radiation. Okay. Now see here. This is the object. Okay. This is any object. Okay. This object is made up from a material. Okay. So this is the material. Okay. Now see here, when a thermal radiation falls on object, when thermal radiation is falls on object. So this is the thermal radiation. So this thermal radiation, okay, so let us thermal radiation falls on the object, okay, then the some part of this thermal radiation is reflected, okay, so this is reflected, okay, some part of this thermal radiation is transmitted, okay, some part of the thermal radiation is transmitted and some part of the thermal radiation is absorbed, okay. So see here, the thermal radiation is falls on the object, okay. Suppose we consider this is the object, okay, object of material. The thermal radiation is falls on that object, then some part of the radiation is get reflected, some part of the thermal radiation is get transmitted, and some part of this radiation is get absorbed by the body. Okay, so now see here. This is an object. Okay, this is the object. Okay, let Q be the total amount of heat which is falls on the object. Okay, so I can write here Q is the total amount. Q is the total amount of heat. Q is the total amount of heat. Okay. So from this total amount of heat, some amount of heat is get reflected. So this is QR, that is reflected. Okay. So QR be the amount of heat, is reflected, amount of heat is reflected. Okay. Now some amount of heat from the total energy is get transmitted. here QT is the transmitted, that means QT is the amount of heat is transmitted, amount of heat is transmitted. Okay, now some amount of heat from the total is get absorbed, so QA. Okay, so QA with the amount of heat is absorbed by body. Okay, understood? See the diagram. Okay, let Q is the total amount of heat. Okay, so the total amount of heat falls on the object. Okay, so from this total amount of heat, the some amount of heat is reflected. Okay, and some amount of heat get transmitted. Okay, and the some amount of heat is absorbed by the body. Okay, so we can write from this, we can write the total amount of heat Q is equal to amount of heat is absorbed plus amount of heat is reflected plus amount of heat is transmitted. Okay, so calling it equation number 1. Okay, now divide this equation or divide on both sides by Q. Okay, that means divide this equation by total amount of heat. Therefore we can write Q upon Q is equal to QA upon Q plus QR upon Q plus QT upon Q. So Q upon Q, okay, Q upon Q is equal to 1. Okay, Q upon Q is equal to 1. Therefore Q upon A is known as coefficient of absorption. So we will discuss about these terms in next point. Okay, plus QR upon Q, which is known as coefficient of reflection, and QT upon Q, it is known as coefficient of transmission. Okay, sorry, Q upon Q is equal to 1. Okay, so this is the most important equation. Okay, now see here. So first we will discuss about coefficient of absorption. Coefficient of absorption. Coefficient of absorption or absorptive power or absorptivity. It is also known as absorptivity or absorptive power. Okay, now see here, we have substituted or QA upon Q is replaced by A. A means coefficient of absorption. So from this we can write what is meant by coefficient of absorption. The coefficient of absorption is the ratio of, which one? Ratio of amount of heat is absorbed by the body to the total amount of heat. Okay, so it is the It is the ratio of amount of heat, is absorbed, by body, to total amount of heat, So we can write A, coefficient of absorption, absorptivity, or absorptive power. So coefficient of absorption is equal to, it is the ratio of amount of heat is absorbed. So QA divided by total amount of heat. So we can write coefficient of absorption is equal to QA upon Q. Okay. Next one. So this one is the coefficient of absorption. Next one, coefficient of reflection. Next one, that is coefficient of reflection. Okay, it is indicated by R. Coefficient of absorption is indicated by A. So we can write the coefficient of reflection is defined as, it is the ratio of amount of heat is reflected to the total amount of heat. Okay, so it is the ratio of amount of heat is reflected to total amount of heat. So coefficient of reflection is indicated by R. So R is equal to QR upon Q. This is the formula for coefficient of reflection. Okay. Next one, coefficient of transmission. Okay. Similarly, we can write the coefficient of transmission is defined as, it is the ratio of amount of heat is transmitted to the total amount of heat. So we can write it is the ratio of amount of heat is transmitted to the total amount of heat. Okay, so we can write the coefficient of transmission is indicated by T or PR. Okay, so which is equal to QT upon Q. Okay, so this is the coefficient of transmission. Okay, understood? See here, I can now see here, I can revise again. So see here, the total amount of heat is falls on an object. Okay. From this heat, the some amount of heat is reflected, some amount of heat is transmitted, and some amount of heat is absorbed. Okay. Now see here, let Q be the total amount of heat. Okay. QR be the amount of heat is reflected. Okay. QT is the amount of heat get transmitted, and QA is the amount of heat absorbed by the body. Okay. So from this we can conclude that total amount of heat is equal to amount of heat is absorbed by body plus amount of heat is reflected plus amount of heat is transmitted. Okay. Now, so divide this equation by Q or divide it on both sides by total amount of heat. So we get Q upon Q, QA upon Q, QR upon Q, QT upon Q. Okay. So we get Q upon Q1, QA upon Q is the coefficient of absorption. It is indicated by A. R is the coefficient of reflection. T is the coefficient of transmission. So these terms are explained here. So what is meant by coefficient of absorption or absorptive power or absorptivity? So see here, it is the ratio of amount of heat. It is the ratio of amount of heat is absorbed by the body. Okay, to the total amount of heat. So coefficient of absorption is indicated by A. So A is equal to QA upon Q. Okay. Similarly, coefficient of reflection. Coefficient of reflection is defined as it is the ratio of amount of heat is reflected. Amount of heat is reflected to the amount of total amount of heat. So coefficient of reflection is indicated by R, so which is equal to QR upon Q. Similarly, the coefficient of transmission, so it is the ratio of amount of heat is transmitted, okay, to the total amount of heat, to the total amount of heat. So coefficient of transmission is indicated by T, so or TR. So TR is equal to QT upon Q. Okay, these are the basic concept. Okay, now we are studying some special cases. So first one is the perfect transmitter. Okay, perfect transmitter. So we already learned the equation A plus R plus T is equal to 1. Okay, A means coefficient of absorption, R is the coefficient of reflection, and T is the coefficient of transmission. Okay, now when we say that object is perfectly transmitted. Okay, now see here, suppose this is an object. Okay, if the total amount of heat is incident on object or falls on that object, then that total amount of heat is get transmitted. Is get transmitted. Is get transmitted. That means there is no absorption. QA is equal to 0. Okay, there is no reflection. That means QR. There is no reflection. That means the amount of heat is reflected, which is equal to 0. Then, if these two conditions are satisfied, then the given object is perfectly transmitted. Okay, so we can write 0 plus 0 plus t is equal to 1. So t is equal to 1. Okay. So this is the coefficient of transmission. Okay. So if this condition is satisfied, okay, if this condition is satisfied, then the given object is perfectly transmitted. Is perfectly transmitted. Okay, or that object is known as completely transmitted object. Okay. Now next one, diatominous. Second case, diatominous. Okay. So how we say that the given object is diatominous? Okay. The substance through which heat radiation can pass, substance through which heat radiation can pass, is called diatominous. Now see here, I can explain this how it is a diatominous. Okay. Now see here, this is our object. Okay. So the total amount of heat is incident or falls on that object. Then some amount of heat is transmitted, some amount of heat is reflected, and some amount of heat is absorbed. Okay. So we know that the condition, coefficient of absorption plus coefficient of reflection plus coefficient of transmission is equal to 1. Okay. So in this condition, the coefficient of transmission is not equal to 0, but less than 1. That means the value of t lies between 0 to 1. Okay. So then that given substance is diatominous. Okay. So diatominous substance is good absorber, is neither good absorber nor good reflector. It is neither good absorber nor good reflector. So this is diatominous. Now next one, third case, anthraquinous. Third case, that is anthraquinous. Okay. So see the substance which are largely opaque. Substance which is largely opaque. Opaque means from that object no heat can be transmitted. Okay. So opaque to thermal condition, that is does not is heat does not transmit. It is does not transmit. Okay, that means T r or T is equal to 0. Okay, so therefore we can write A plus R is equal to 1. A plus R is equal to 1. So this is the thermometer. Okay, now fourth one, good reflector. How we can say that the given object is good reflector? Okay, now see here, we know that the condition A plus R plus T is equal to 1. Okay, when the given object is good reflector, when there is no any absorption of heat, there is no any transmission of heat, therefore R is equal to 1. So the given object is good reflector. Okay, and last one, that is perfect black body. That is perfect black body. Black body means that object is totally absorb that heat. Okay, so that is R is equal to 0. That means there is no any reflection, there is no any transmission. So we get A plus R plus T is equal to 1. Therefore, substituting this value in this equation, we get A is equal to 1. Okay, when A is equal to 1, then the given object is perfectly black body. Okay, these are some special cases. Okay, now see here, I can repeat. So first case, the given object is perfectly transmitted. How we can say that the given object is perfectly transmitted? The amount of heat is incident, total amount of heat is incident on an object which is as it is transmitted, Okay, so A coefficient of absorption is 0, coefficient of reflection is 0. That means the coefficient of transmission is equal to 1. Okay, so that object is known as perfectly transmitted. Next one, diatherminous. In this condition, the transmission coefficient of transmission is not equal to 0. That means that the value of T is lies between 0 to 1. Okay, lies between 0 to 1, not 1. Remember it. Okay, and the diatherminous substance is not good absorber, is neither good absorber and nor good reflector. Okay, and next one, atherminous substance. Okay, in this atherminous substance which is largely opaque, that means there is no any transmission of heat. Okay, so that is Tr is equal to 0. So we get A plus R is equal to 1. Okay, and next one, good reflector. What is my good reflector? There is no any absorption of heat and no any transmission of heat. So coefficient of absorption is equal to 0 and coefficient of transmission is equal to 0. Therefore, substituting in given equation, we get R is equal to 1. And this is the most important, perfect black body. Perfect black body means the given amount of heat to that object is as it is absorbed. Okay, so R is equal to 0, T is equal to 0, so we get A is equal to 1. Okay, so this condition for perfectly black body. No any perfectly black body is find out in this world. Okay, the black platinum is absorbed 97% of heat falls on that object. Okay, remember that 97% of heat is absorbed by platinum or black platinum. Okay, so this is the perfect black body.